So welcome everybody and good evening. This is the Data Science Career Pathway panel. I am really excited that you all have joined us today for this interesting and informative session about the ever-changing and evolving field of data science. So my name is Christine Breyer. I am the internship coordinator with the Career Center, and I'm also joined by my colleague Gianna Moore, who was our student program advisor. So Gianna, do you want to say hi really quick?
Welcome, everybody. We're really excited you're here. I know this is going to be an excellent panel, so enjoy.
Absolutely. And Jana's actually going to be helping me moderate the Q&A chat box. So if you do have a question during this panel, feel free to put it in the chat box, and we're going to get to it at the very end of the presentation. So what is data science? We're just going to go right into it. And I was going to talk about data science, give a brief explanation, but I have a theater background. This isn't my forte, but we do have experts here who are going to talk about data science. And I'm going to actually hand it off to the chair of our computer science department at SBCC, Natalie Gables, who will be able to accurately describe data science. So Natalie, you want to take it away?
Well, now you put me on the spot. Data science, people have many different definitions of it. There's really no one definition of it. But what we do know is that it has to do with data, and it's basically trying to either answer a question with data and or visualize or make informed guesses. And a lot of it is often based with some foundations of computer science, some foundations of statistics. And then you, of course, need an expert that's an expert on what the data is about, what story is it about? Is it about healthcare data, or is it about business data, or about whatever else data? So we invited some great panelists today that will tell you a little bit more about how they are data scientists. So I'm gonna not really give the one definition of data science, because there's many facets and colors of it. But what I would like to share is just a little bit about where SBCC stands with data science opportunity in terms of career pathways. And really, I jumped into this as a computer science professor sometime in actually, the first time I really was looking more into data science was not that long ago. I had worked with data, but not really offered any data science classes. But then I went to one or two conferences that were more focused on data and machine learning. And in 2019, I was invited to apply for a grant, and then we at SBCC joined the Central Coast Data Science Partnership in 2020 with UCSB, Cal Poly, and CSU San Bernardino. We also joined the California Alliance for Data Science Education. And what these programs are doing is bringing new degrees, new four-year degrees to many of the institutions in California, and trying to kind of streamline that pathway so that people from community colleges can transfer to four-year institutions and get a bachelor's degree in data science. Something that's still more in the works in some universities, and others have already established bachelor's programs. And through the Central Coast Data Science Partnership, I've been working here with Alex Franks, is also one of the panelists today. He's a professor at UCSB. But we've been able to have students participate in the fellowships, and we're lucky to have Piero here today, who was part of the summer internship last summer. And then Zoe, who was a fellow at UCSB as a UCSB student last year. So you'll learn more about those opportunities from them. But in terms of courses at SBCC, we started the first data science course that we offer. And what do you learn in that course? It's really meant as an intro course and an intro course to data science. So you're getting introduced to computer programming and statistics. So you don't have to have any background, so it's no prereqs. And we learn about creative ways to solve problems with data and work with real world data sets from all kinds of disciplines, from the healthcare, from sports, from we look at books. And I know some of my students are on here today too. So they already have had a little flavor of it. We work with the Python programming language, and of course, with data, there's always inherent uncertainties associated, and with exploring data, so we talk about those aspects as well. So right now, the applications just opened for the summer 2022 research experience at UCSB. So I also put a link on there, and I'm sure we will pass that on with a follow-up email to everyone here today. The applications close March 31st. So if you like what you hear from Piero's experience and from Zoe's experience, and you're interested in applying to do some research, I believe is it 8 weeks? I think it's 8 weeks, right? Piero, can you remind me, is it 8 weeks or was it 8 weeks?
Mine was actually 10 weeks.
Oh, it's 10 weeks. See, I have my helpers here today. So it's 10 weeks over the summer, and this coming summer, as long as everything goes as planned, it's in person, and there's a stipend and an option with on-campus housing as well, depending on your preference. So check out the link, and I think that's where I will stop because we have lots to learn from our panelists. So I will pass it on to Christina, and she can go ahead and start with the questions.
Thank you, Natalie. So we have some amazing panelists that will be sharing their knowledge and journey in data science. I'm going to introduce everyone first and do some panel questions, then open it up to some Q&A at the end. So feel free to put your questions that you might have in the chat box. To start, we're going to introduce Alex Franks. Alex is an assistant professor in the Department of Statistics and Applied Probability at UCSB. His research interests include covariance estimation, multivariate analysis in high dimensional data, errors in variable models, causal inference, missing data, and spatio-temporal methods. He works on applications in computational biology and sports analytics. So welcome, Alex. Next, we have Carmen Galaz-Garcia. She was born and raised in Mexico. In 2015, she obtained her bachelor's degree at the University of Guanajuato. And last year, she received her PhD in mathematics from UCSB. Currently, Carmen works as a data scientist at the National Center for Ecological Analysis and Synthesis and seeks to collaborate in projects to help protect the environment. Apart from mathematics and environmental data, she is also interested in supporting the advancement of underrepresented groups in science and higher education. For the past 10 years, she has founded and participated in multiple successful programs to make STEM accessible to people of all ages and backgrounds. Welcome, Carmen. Next, we have Luby Boskic. He received his MS in mechanical engineering from UCSB in 2019. He then started working as a software engineer data scientist with the Department of Energy right after graduating, where he worked on various machine learning and computer vision projects. In October 2020, Luby joined CJ Affiliate as a senior data scientist. At CJ, he has been working on various client analytics projects and recently started on the solution side, working with longer-term projects, which can scale to a whole affiliate network. So welcome, Luby. Thank you for being here. And then next, we have two student panelists, which I'm really excited to introduce. We have Piero Trujillo, who is an SBCC alumni and third-year transfer student at UCSB, where he is majoring in statistics and data science. He participated in the Data Science Fellowship at UCSB last summer, offered by the Central Coast Data Science Partnership. This project focused on El Niño's effect on ocean temperature, species abundance, pH levels, salinity, and ocean depth. Having previously attended the same career pathway panel as a prospective student, Piero is excited to be on the other side of the presentation as a panelist. So welcome. I think that's an awesome little segue there. And then we have Zoe Holzer, who is also an SBCC alumni. Zoe is an undergraduate senior at UCSB pursuing a major in statistics and data science and a minor in anthropology. Zoe transferred from SBCC as a mathematics major and currently still tutors math there. She was able to participate in the 2020-2021 CCDSP Data Science Fellowship at UCSB, as well as help run their summer internship. She hopes to provide an insight of her journey towards careers involving data science. Well, welcome everyone. Just reading that off, you all are so accomplished and so involved in the field, and I'm really grateful that you're here just speaking about this and letting us know what you do. So our first question is actually going to be for Alex, Carmen, and Luby. Could you provide us with a synopsis of your career path, education? What is your job now, and how did you get to where you are today? So if Alex, if you'd like to start, that'd be great.
Okay, thank you. Well, I have a somewhat unique career path in the sense that I've always been in school, and I still am. So I personally always like to learn. So I did my undergrad on the East Coast, and I knew at the end I was really interested in data, and I was really interested in particular what I think then I would have called data science, although I don't think at the time data science was a term that was really used. I felt like I still needed to learn these tools in more depth, and so I decided to go to grad school. From there, I was just, I really enjoyed teaching. I really enjoyed research. And so I kept pursuing that. And I ended up here at UCSB as a professor in the statistics department. So teaching statistics classes and in particular data science methodology.
Thank you. Carmen, same question, a little synopsis of your career path and what you currently do and how you got to where you are today.
Thank you. So as I mentioned, I did my undergrad in Mexico. The education system is a bit different, but I have probably what would be considered a major in math and a minor in computer science. So I was always interested in coding. I really enjoyed it. I must say I left it aside during my PhD in mathematics. I did do some Python coding for my research, but I had never really explored this like data science path. And at a specific point in my PhD, I just thought, well, I would really like to contribute to what I consider to be a really big challenge right now, which is just our environment and how, all the problems related to that, and also the solutions that could come for it. And I figured a way for me to enter that cause would be through coding and through learning more about environmental data science. So it was more like a means to an end in collaborating towards these environmental solutions. And towards the end of my degree, I took classes that were specifically about environmental data science, and then started working in NCS, which is a bit of a middle ground between like a non-academic position and academic position in terms that I do not teach, but is still within a research setting. And in my day-to-day work, I'm looking aside, I have some notes so that I do not derail, but I collaborate in implementing and designing workflows that have to do with a lot of really big data, environmental data, work a lot with satellite images and also long-term climate data. And then our goal is to help design these tools that can help you assess the health of ecosystems in a way that is actually repeatable, because there's a lot of issue with making an assessment once, but then you cannot repeat it. And if you cannot repeat something across time, then you cannot really evaluate change. And I think that's something really powerful with implementing a coding workflow. Like if it works, you can actually repeat it. So that's something I'm currently working towards.
Thank you. That's awesome to hear about. Luby, same question.
Yep. So I got a bachelor's degree in physics and math on the East Coast. And then I came out here to do my master's at UCSB, where I thought I could combine those two things and do mechanical engineering. But quickly I started doing applied math. So I was in the mechanical engineering department and I did a lot of applied math, and I was writing algorithms for looking at essentially residential buildings, doing, my thesis was looking at residential buildings, looking at essentially the energy consumption and how to optimize that. So I wrote some interesting algorithms using the Koopman operator. So I learned a lot of operator theory and math. And then I applied for my first job, started working as a software engineer, data scientist with the Department of Energy. And there I was doing a lot of not much data was being collected on certain problems that we were working on. So it was very niche and data that you can't find online. So it was small data sets, and we were essentially making custom algorithms for acoustic detection or computer vision. And that was going great. I loved doing data science for that part. And then, I was also doing software engineering. And now, just to kind of give you an understanding, I learned all my coding in grad school. So when I came to California, that's where I first started coding in Python, C++, JavaScript. So I learned everything, while I've been here. And then I started noticing that I really liked data science more than the software stuff I was doing. And then in October, I made a career change where I started working at CJ Affiliate, and it's been great. My day-to-day is working with big data now. So that's a big change. Is these data sets are very large, and I've been working on the product solution where I look at something called cross-channel customer journey, which now I start looking at click data. So I don't really look at time series data anymore. So it's just a different data type that I'm looking at, and I can go in more detail later. But that's pretty much it.
Thank you. It's really interesting to hear about the variety of disciplines, like academic backgrounds, that are all in all of your stories. So thank you for sharing. To our student panelists, Piero and Zoe, how did you first get interested in data science? Zoe, you can go first if you like.
Okay. I first got interested in data science through I guess statistics. I went into college as a psych major, but I really, really liked my statistics class. And I really liked that it seemed really applicable, because I was interested in a ton of different things. And I had trouble deciding, but I realized that with statistics, you could do a lot of things. And then so when I transferred to UCSB, my major actually ended up being statistics and data science. And I got into the fellowship, the data science fellowship. And I think that's when I really, actually learned that it was different than statistics. And I really liked it. We were able to do some projects through that. And, the lower divs for that major are all math. So it was really cool to actually be able to apply the math and the coding to things that could help the world, the real world. It was just cool to see how many ways you can apply these seemingly very abstract methods to things that can really have an impact on people in the world. So yeah, now I'm super interested.
Thank you, Zoe. Piero, same question.
Yeah, so I was first introduced to data science by Natalie Glevels, who was my C programming professor at the time. And I was originally a computer science major, and I didn't even know data science was an existing specialization. But after she emailed me about a unique opportunity to take part in a Data Science 1 course at UCSB, I found the machine learning topics and the applicable homework in that course to be super interesting and fun. So then I decided to take Data Science 2 and the following semester. And so that's how I knew I wanted to specialize in data science, because I really fell in love with that specialization and just connected to it more. So I'm definitely thankful for her leading me to that conclusion.
Awesome. Thank you so much. I love hearing from our SBCC alumni. It's always great. Back to Alex, Carmen, and Luby. what you all spoke about your educational path, but what education do you need for the work that you do? What jobs can one get with a 2-year, like an associate's degree, versus a bachelor's or a graduate degree? And what are the earning potentials or job growth? I know that's a long question, so I'll put it in the chat box. And Alex, if you want to start first.
Okay, I'm thinking about an answer because it's not an easy question to answer. I think first of all, you can do data science with just a little bit of exposure. Natalie's course on data science for all is going to take you a long way. Now, first, I think about like the most important skill set is just developing a conceptual understanding. Part of being a good data scientist is it's like reading or writing. It's a way to sort of view the world. When you read the newspaper and you see data in the newspaper, how do you think about that data? So in terms of the education for the work that you do, I think it depends quite a bit. There's a lot of jobs that require something like Excel or the ability to manipulate a spreadsheet. Then if you want to get like a job as a data scientist, typically titled as a data scientist role in industry, that might require a bachelor's degree or even a master's degree where you have a little bit more experience with programming, with machine learning, and with statistics. So I guess that's my answer, although maybe some of the actual data scientists on the panel have a better answer.
It's a great answer, thank you. Carmen, do you have a response for that?
I think I totally agree. I think that to start working and analyzing data, you really just need to get, your hands dirty. Like just, pick a project, a topic you're interested in. There are so many data sets that you can download online and, just play with it. Really, that it's like a low access relatively. And I would say also, something that I find that is very important, and that it's not like you study something specifically to get it, but through education you get it. It's a mindset of just like trying as many things as you need to make something work. I feel like I got that mindset through mathematics, in which you say, I'm going to try as much as I can. I'm going to ask for help. I'm going to Google this. I'm going to Google this in a different way. And I think having that experience with approaching problems is something you can get through a lot of scientific disciplines. So really cultivating that through whatever you are studying is something that is really going to pay off when you are going to tackle any kind of problem in general, and specifically about data science. There's also a lot of information out there. So a lot of it is just, knowing how to answer the right questions to really access it. And just kind of like not giving up in the, I'm gonna get to point B.
Thank you. And I love that you said, get your hands dirty, just start doing it, working on projects, figuring out what it is that you like about it. So great answer. Luby, same question.
Yeah, Alex and Carmen, you really hit it right on the head. It's perfect. I would say, with getting your hands dirty, Kaggle, right? I'm sure many of you are familiar with it. Kaggle competitions, and there's lots of different data sets that you could get started with and progress that way and really learn data science that way. I think a big thing with maybe I would say furthering the education, going for a 2-year, 4-year, maybe a master's, you might get more domain knowledge, which is very important, right? Me doing more physics and applied math, I got a lot of domain knowledge in some of the things that I was working with there. So I was very good with maybe time series data, but not so good with something like I'm working now, click data, but you can learn it, the more you work with it, the better you're gonna get at it. So I would say, in terms of the jobs that you're gonna get, I think a 4-year degree will get you pretty much anywhere. And the further advanced you go, you can get into more specialized jobs. So for example, if you're trying to work at like Google X, which does like a lot of R&D with like unlimited resources, you might need a PhD to get in there. So, right, there's some jobs that I think you're set if you have a bachelor's. But then if you want to look even further and get even more specialized or work in a very niche topic, you might have to go for a graduate degree and progress further. And in terms of growth, I think it's forever expanding in data science. So job growth, yeah, I don't think you have to worry about that.
Thank you. And I think those are really encouraging things to say to our students as well that are interested in this field. Back to our student panelists. Please provide a brief highlight on your data science experience so far and what projects you are working on or have worked on. And Piero, you want to go first?
Sure. So the highlight of my data science career so far is certainly the fellowship I participated in last summer, and that was hosted by the Central Coast Data Science Partnership at UCSB. And I was part of the CalCoffee group, which stands for California Cooperative Oceanic Fisheries Investigation, with 4 other students. So we were given a data set of ocean characteristics and fish larva abundance, all collected off the California coast. And our group had a focus on the effects of change and warming waters on marine life. So we then chose to explore El Niño's effects on ocean temperature, along with species abundance, pH level, salinity, and ocean depth. And we actually found a strong correlation between ocean temperature, pH levels, and salinity. And in this project, we got to use hypothesis testing, linear regression, and a variety of visualizations such as scatter plots, maps, and 3D graphs to find these relationships between the water characteristics in our data set. Our linear models actually indicated that there was a highly positive correlation between ocean temperature and pH levels, and that came out to be 0.86. So 0.86 is your R value, and the closer it is to 1 or -1 means that the more highly correlated these two features are. And then we also found a highly negative correlation between salinity and pH levels, which was -0.895, and ocean temperature and salinity, which was -0.815. And then we also created a heat map of our data to showcase the change in California anchovies abundance throughout the season over the span of the years in the data set. And in the end, we concluded that El Niño not only leads to warming waters, but also contributes to the decrease in salinity and increase in pH in the ocean. So overall, it was a great way to learn how data science teams work. And I recommend any of the students listening to apply for that fellowship. And then if there's a little bit of time, I just want to mention that the most fun and whimsical project I actually created was my first ever project in my Data Science 1 class, where I helped create a legendary Pokemon classifier using a data set of all the current Pokemon at the time. And then you would take different stats like defense, attack, special attack, and feed it into the algorithm. So you could examine a row, which was a given Pokemon, and then classify whether it was legendary or not. And it could classify to 95% accuracy. And I thought it was really fun and cool, so I could find undervalued Pokemon for the next playthrough.
That's awesome. Thank you for sharing. I think that's so cool. And thanks for emphasizing, if you're on the fence to apply for this fellowship, for this internship, do it, apply. Like, this is so great to hear about that you all did. So Zoe, same question.
Well, first of all, that's a really cool project. And I have done, they're a varying scale, but I've done like 6 projects now. Well, not done, I've worked on 6. The biggest one was also through the fellowship, but through the year-long one at UCSB. I actually worked with Alex. And our project was about the correlation between A1C levels and various factors. A1C levels have to do with diabetes, so we worked with the Sansum Diabetes Research Institute, to look for correlations between blood sugar level and factors that the cohort reported. And also this kind of goes along with what someone asked in the chat, but that project definitely made me understand the impact of data science on real people, because, you know, diabetes is a impactful disease, and this project is still ongoing. So it was just, I don't know, it just felt really cool to be able to work on something that could, in the long run, you know, maybe help people if we can gain some information from it. Besides that, I also helped work on the SBCC summer internship, but I actually was like, I don't know, like a TA or something. I helped work with the other project, which was about bee interactions, and just kind of help the students like focus on where they wanted to go with it. Besides that, I have a minor in anthropology, or hopefully I will, and I've used some data science to work on two different anthropology related projects. They were both pretty small, but that was pretty cool too, because you can really apply data science to like almost anything you're interested in, which I think is the biggest appeal of it, at least for me. Yeah, that's about it.
Thank you, Zoe. It's really great to hear all the projects you've been working on. Our next question for Alex, Carmen, and Luby. When hiring, what do employers look for in terms of internships, skills, transferable skills? What are some things that you all think? And we can start with Luby on this one.
Yeah, so I think the number one thing when I was getting hired at both of my jobs, it was right, I needed to display some knowledge of me being able to code and do some basic data analysis, search algorithms, things like that, which I think is relatively standard nowadays, pretty much for any company. They just kind of want to know that your technical skills are there. But I think something really important for the job that I'm doing now, it's communication skills and like presenting skills is very important, because right now I deal with stakeholders a lot. So essentially people that might use my work for, you know, to do their jobs. And I might be creating a solution that will impact the whole business. So I have to be able to, you know, technically do the work, code the work, display it in a nice way where I use tools like Tableau that'll, you know, for BI purposes. And I have to be able to display my work and explain it to these people that, you know, maybe don't have a sound knowledge on the things that I'm doing right now. But like, I have to be able to convey the message of why the work I've done, why is it valuable, and what insight does it provide them and provide, you know, the business, the people that they're talking to, the advertisers, you know, Nike or hotels.com, these big advertisers that we have in our network. The tools I'm designing is going to be used for them, but our business end is the one that's interacting with them. So I'm the one that, you know, does the technical work, but then I also have to, you know, do the presentation and communicate the work. So I think that is very important. And during my interview at CJ, that was a lot of stuff that they were, you know, asking me questions. How do I communicate my work? How are my presentation skills? Things of that nature is very important.
That's a great point, and I'm glad you brought up some of those soft skills, because I know we've been, you know, talking about technical skills, but being able to articulate and communicate what it is you're doing, that's so important. So thank you for bringing that up. Carmen, same question.
Yeah, kind of going off the topic on showing that you can communicate what you do. I think having a, you know, a personal website where you can write a blog post about, you know, your awesome Pokemon classifier, or, you know, how the work you did relates to health issues and how you work with like local data. I think that is super, super important. And that's something that you can link to in your resume. And I think people are interested in like seeing something visual that they can, click around and, really this like show, don't tell, sort of like, I'm saying I know how to do this, and this is the evidence that I know how to work on that. So I think having those communication skills, you can demonstrate them in that way. That seems to be very valuable. And at least for me, I think also I made a big transition from more like of my math research to this environmental position, data science position I have now. And I had, made explicit efforts in get acquainted with this environmental data sets and the tools needed there. But I think also finding this like work culture match. So I also have like expressed like real interest in environmental protection through the personal projects I had already worked in. So I thought that match was like very important when I was transitioning, not only saying I can do the technical stuff, but I can also communicate with the domain experts that are going to be working on. So like you do not have to be an expert in everything, but you have to be able to communicate with the other people in your team. So that match, I think, is very important if you are not only applying the technical stuff, but collaborating with people outside your expertise.
Great. Collaboration is key, right? So that's a good point. And Alex, your thoughts?
Yeah, so I think, one of the things that I think maybe we all think of when we think of data science is statistics and computer science and math. But I hope what you're hearing, which I just listening myself, is environmental science. We talked about this diabetes research project, all of these domains, all of these sciences that are coming up. And so just building on some of what was said, find something that if you find something that you're excited about, it can be almost anything, and you can find some data related to that thing you're excited about, then you have an in to start exploring. And that's something that you can talk to an employer about, because I think both Carmen and Luby mentioned one of the things. First of all, I should say I haven't, I'm not in industry, so I'm not hiring data scientists, but one of the things I sort of understand is that they want to hear from you about a project that you've worked on. And that's a way to learn about not just your technical skills, but also your communication skills and the way you share ideas and so on and so forth. The one thing I just wanted to add, because it's come up this fellowship a couple times, if you're still not convinced, I just wanted to add a few more things because it touches on a lot of what we've discussed. So Piero and Zoe were in 2 projects. Just to give you a sense of the breadth of data science in some of the projects. This year we have a project related to neuroscience, brain science. We have a project looking at what we call remote sensing data or satellite images. We have a project working with a company in Santa Barbara called Evidation Health. So if you have an Apple Watch or like a Garmin, they look at sleep data or heart rate data that comes from your watch and understands patterns there. We have a project on political science and looking at survey data related to climate change. We have a project with Appfolio, which is another big company in town. So I'm just saying this as a way of saying that for me, don't get hung up on the technical skills, because just to reiterate, the soft skills matter a lot, and find that thing that you're passionate about. Put the emphasis on the science, not just the data, and use that as an in. So I think that's my sort of roundabout answer to that question.
No, that's perfect. And I love that you brought up the fellowship again. We're going to keep plugging that. Everyone apply. So briefly, since we're with you right now, Alex, but what do you enjoy and what are the challenges about the work that you do?
For me again?
Yes.
So I think, actually, I think Zoe mentioned this. So one of the things she likes about statistics is how applicable it is. So there's a quote, I've used it before, which is, it's a quote by a famous statistician. And they said, the best thing about data science is that you get to play in everyone else's backyard. Okay, so that's part of the fun of it for me. I've done applied statistics in a variety of areas. So I do a lot of my work in biostatistics, biology, but I've also been involved in, for example, something as different as sports analytics and basketball. So I was consulting with an NBA basketball team for a while. So, you know, totally different things, both of them really cool. And that's been in, you know, statistics and data science has been into all of these really exciting, exciting worlds for me. So that's what I find exciting. What I find challenging, well, that's a really good question. I think the way I would summarize it is that what's the best way to say it? The data can often surprise you. So what I try to tell students is that there's many different stories that could be consistent with a given data set. And so sometimes we get fixated on a story that we really like, and it turns out that that story is not true. It's not borne out after further investigation. And so you, as a data scientist, we have to be very careful in thinking about our analyses and thinking about our assumptions and thinking about all the possible conclusions that are consistent with some of the data sets that we have. So I guess that's maybe the biggest overarching challenge.
Thank you. Same question, Carmen.
So something I really enjoy about my job right now, and I know I always liked it, it is the coding. I must be honest, I do enjoy doing it, and I like just like, you know, cracking all the little puzzles to make something work. I find that really satisfying. So really kind of, I really like that. So I like the technical aspect of my work. I must say, I also really like the end goal. I think that that's something that really motivates me a lot. Just like thinking that what we're working towards as a team will be something that will be deployed and implemented. Like that for me is huge. Like seeing that something that you put so many hours into can go into the real world. I think that's a huge thing for me, something I'm very excited about. And then the challenges, I think, also working within a team, I think there's also times where you can have to work by yourself. So I think that also kind of, you know, not losing the sense of direction of, you know, where is my project going, you know, being able to iterate over it several times. That's also something that I found challenging, but like really rewarding when we get to get it right and really say like, yes, this is the direction we were looking for, and this is where we're gonna move towards.
Thank you, Carmen. Luby, same question.
Yeah, so what I love about it is also the technical aspect, right? The coding is fun, the end goal, cracking the puzzle is a lot of fun. And it's the cool thing about what you can do with the data, right? Like you can predict things. So in my master's, my thesis was on pretty much trying to predict indoor temperature of a house and how to make it more efficient with heating and cooling. And I essentially wrote 2 papers on this, and I filed for 2 patents with UCSB because we saw that, you know, you could do some simple things in a residential building, and not new buildings, so old buildings, you know, that have been built before, you know, 1980, to retrofit them and help you save money in your house. We were able to show that we could save anywhere from $100 to a couple of hundreds of dollars per year on your energy bill. So it's kind of cool that, you know, I use data science techniques to be able to do something like this and have something be applicable to everyday life and possibly to everybody, right? So it was really cool to do that. Now with all that comes challenges, right? A big challenge with stuff that I'm doing now, and I mentioned it before, is the domain. I'm not very familiar with the work that I'm doing now because it's a lot of click data. And you know, honestly, prior to working here, I was not very familiar with click data. I've never heard of it. I've always worked with data that's a time series. Time series data is nice to work with. I loved it. So it's those are the challenges I'm facing, is kind of understanding how to piece that puzzle together, how the data really fits in together. You know, now that I've done almost, I wouldn't say it's a career change, but I've done definitely a change of the work that I'm doing. So now it's a lot of sitting down, reading papers. I'm reading, academic papers that are coming out to this day, right? I've been out of grad school. I thought I would be done with academic papers, but that's not the case. I'm still sitting here reading papers, that people are publishing. Maybe you might be on those papers, working on them with people, and I'm reading them. And that's the fun thing is, right? You come to challenges in the work, and, there's speed bumps that I'm hitting. I'm not a computer science person either, right? I don't have a computer science degree. I'm not perfect with data types and all the algorithms that out there are the optimal things. And those are speed bumps sometimes. Me working with big data, I need to make sure I'm using the optimal stuff. I can't just run for loops, right? I need to use the most efficient stuff, because I can't go through 50 terabytes of data and expect for this thing to ever run. So, there's challenges, but you have to work at them, and you will get the answer at some point.
Thank you. While you were talking too, I was just hearing it's almost like solving a puzzle, right? That's what it kind of sounds like. It's really cool. I've noticed that there's so many great questions in the chat box. So we're gonna wrap it up so we can get to these Q&As from our audience. So I would like to end on a final question for everyone. If you could briefly give any advice for students who are pursuing an education to work in this profession, and to our student panelists, and also just kind of where do you see yourself in this career in your future? So we can start with Piero, if you like.
Okay. Some advice I would say to a student right now is just to start I know this was already said, but to work on passion projects over your breaks. And I know it can also be hard to work while you have corresponding classes. And then also really paying attention to your math classes, and trying as best as you can, because so far it just all comes back to you, like that first, second calculus class, 150, 160, that you thought you were done with. Nope, it's coming back to you and piece that 120A. So yeah, really brush up on your calculus. And then as far as I see myself in the future, once I graduate from UCSB, I would like to pursue a career as a data engineer or a data analyst. And right now, I'm currently fascinated by geographical data, and I think it would be really fun to work with it in the future, since I think geographical data has a really big impact in data science. And I kind of came to this conclusion after watching a video Vox did on Phoenix, Arizona, which is currently the hottest city in America, where they found that the hottest parts of the city are also the poorest. And because of that, I wanted to see if there was any geographical data that could unearth similar problems in Santa Barbara. So then I can find these problems, present them to the city council, and see if we could find a solution to them. And then my fellowship also dealt with geographical data, so I already have a positive experience with it. So that's why I think that's the way my future could go. And then one more thing is that it's also a personal dream of mine to work with Spotify's music recommendation algorithm, because I really like taking the time to find emerging and obscure music. And since Spotify's API is actually free to download and play around with, I've tried to get a head start by analyzing the music for my favorite artists and looking for correlations between their songs and their albums, and personally judging whether I feel like their classifications are accurate. And then I would eventually like to finish that personal project and create an accurate classification model so I can see which features can best match a song with their corresponding album. But yeah, that's my plan and interest for now.
Thank you, Piero. Zoe, any advice for students?
My advice would, it also has to do with math and CS. I've been a math tutor for 3 years now at SBCC. I definitely agree. The stuff from calculus comes up a lot in operative statistics, which I was not expecting. But honestly, I would say, you got to know that stuff, but also I would not like I would not be scared of the math or like be hesitant about the major because of the math, because really that stuff is just like, depending on where you want to go, that stuff can really just be like, the basis for what you're applying. So, in the end, you don't really have to have maybe a perfect understanding of the math part of the statistical theory to be able to apply it well. So I guess I would just say don't be scared of that. A lot of students really seem to have a fear of math. And it's really not about being good or bad at it. It's just being able to fix your mistakes in it. I mean, even my professors, they make mistakes all the time. There's so many typos. But yeah, that, and also, don't be scared of the math. If you're interested in other fields, you can go into statistics or data science with other fields in mind, because in pretty much every field at this point, I feel like there's going to be some kind of niche containing data that they need looked at. And a lot of people I'm interested in like, humanities, environmental science, like anthropology, geology, astronomy, stuff like that. And, a lot of people in those fields don't understand the technical side of it. And it's nice to be able to like work with them to learn more about the field while still being, I guess, helpful with like your own statistical domain knowledge.
Oh, thank you, Zoe. I appreciate that. And to Carmen, Alex, and Luby, do you have any advice you want to quickly give out to students? We have a few more minutes and hopefully we can, I think Luby said he'd stay on a little bit later to answer any questions in the chat. So if you all want to hold on a little bit longer, we can answer some of those questions. But Carmen, any advice?
I think you both, Piero and Zoe, gave some really good advice, especially do not be afraid of the math. But say on the less technical side, I would say reach out to people, people who you think do cool work. Ask them if you can get an informational interview with them. Ask them if you can talk with them for half an hour about the work they do, what tools they work on, what does a day-to-day look like in their work. I actually did that a lot when I was thinking about transitioning into a data science career. And that helped me a lot just to have a better insight of what people do in different companies, in different sectors. So reach out. Also reach out in terms of, we talked about how important it is to develop some data science projects. And I think one of the awesome advantages of being in a university setting is that there are a lot of people with data. So, if there's any professor who you think there's they do cool work, you do not have to wait for a scholarship to open up or like a fellowship or an REU, reach out to that person. Maybe they will include you in a research project or, just be proactive in contacting people. And sometimes that can feel very embarrassing, but you'd be surprised about how many people are willing to, help you or at least guide you or tell you, have you looked at this website? There's this really cool YouTube video. It's really good to just open up. And also in that direction, I say like sometimes, at least it happens to me, I feel like I have to be 110% prepared to apply for something and to reach out to this person. And, I would say like, be less severe with yourself. You do not have to be like perfect in your data science, in your coding skills, in your math skills before thinking that you can, apply for a fellowship or reach out to a professor. So really, go for it. If you're on the fence, apply for that, send that email, take that class. Mm-hmm.
Thank you, Carmen. And Alex?
Yeah. So what Zoe didn't tell you is that I'm actually her professor right now. So when she was saying her professors make mistakes, I don't know if you're trying to tell me something, but no, of course I make mistakes. The advice I guess I wanted to give that I was just thinking of, which might surprise you as someone who teaches, formal statistics classes at the university, is to work on your self-teaching. There's so much you can learn without any formal education. And even in the formal education, you still need those skills. So when it comes to programming, one of the things that you'll inevitably, as you sort of develop as a programmer or even begin as a programmer, you'll inevitably see that you're running into errors. Your code isn't working. Why isn't it working? You get a message you don't understand. And rather, you have to start to develop the skill set to search for that solution on your own, to teach yourself how to do some of these things on your own, because there is so much out there and you're never going to have it all covered in any class. I think that the formal education, I hope, the most important thing that comes away from the formal education is really, I hope, how to learn, and then how to take that and how to keep teaching yourself on your own. So whether that's Googling or finding blog posts or a YouTube video to supplement your education. All of those things you can do right now on your own, wherever you are. Let's say, as long as you have an internet connection and you can start searching out some of those things that excite you.
Thank you, Alex. And Luby?
Yeah, I think what Alex said is the main thing I want to tell people is, yeah, you can learn some of this stuff on your own and outside of your classes, and you really should. A lot of stuff that I did in my job with the Department of Defense, I was working on these small devices and I was trying to install packages for Python with pip install, and it didn't work, right? And you backtrack and you start looking of what's going on. And I started noticing I have architect problems. And, I am not a person who knows much about architect design for like the operating system that, ARM and Arch Linux 64 are different, or what bit that you installed for this package, for these wheel packages. And, you start Googling, you start trying to do your own research, trying to put the pieces together. And, you're not an expert in this, and maybe you're just trying to do the data science, but there's things before that become, automatic, and you have to go out and solve them. And that's how it was, when I was in undergrad and when I was doing my master's. A lot of the stuff in the classes, it's amazing things you learn in the classes that I can't take away from the professors. They've taught me great stuff. But outside of those classes, you got to start applying that, and you're going to run into problems. You're going to run into, problems with your codes that you need to research, like Alex said. And that's a big thing is, being able to, problem solve, maybe not even the very technical stuff, like the data science of what should I do with this data. The stuff that leads before that is really major. And like, that's key, building up to the endpoint, being able to do some of this stuff on your own when you don't have resources to ask. In my old job, I didn't have a subject matter expert that I could go to and be like, hey, how do I do this? You kind of have to do this digging and poking around on your own. And that's really major. Sometimes you might not have a professor that you can ask, how do I do this thing with statistics, or how do I write this code? You have to do that poking and exploration on your own. And that's really major. And I do that today.
Thank you so much, Luby. And thank you to the panelists, Alex, Carmen, Luby, Piero, Zoe. I really appreciate your time, for sharing your journeys, your advice. This means a lot to our students. I learned a lot about a field I honestly had no clue about, so I really do appreciate it. And that's actually going to be it for our presentation. I know we're supposed to end at 5, but there's some amazing questions in the chat box that Jana Mori is going to help me facilitate. So if you want to hang on, feel free to hang on. If you got to go, we totally understand. There'll be a follow-up email with some more information, but I'm going to stop the recording so we can have a little Q&A.